Yeah? Did I hear something? I'm going to carry on. If you want to ask questions, just shout out. Um, I hope you've enjoyed your lunch, dinner, afternoon tea, breakfast, or bedtime snacks during the break. Um, First and first, just a very quick intro about myself. I'm a software developer from Auckland, New Zealand, and I work at a great place called Xero, the beautiful accounting software. Throughout the talk, I would love if you could ask me questions. If you do, just call me Hack or Hux is how my friends call me. So don't be shy. Today, I want to talk to you about regular expressions and parsers. However, before we get into it, I must confess that the title of the talk is inaccurate for dramatic effects. To be more accurate, I think it should be called less regex, more parsers, or try out parsers when regex fails you. But hopefully you get the idea. So is it regex or regex? If you're a fan of trivia, this could be something to spend a few days of your life debating. Unfortunately, today is not the day, sorry. And because English is not my first language, I'm going to be very liberal about it. I'm going to use both pronunciations throughout. So hopefully you don't give me trouble for doing that. There are quite a few good quotes about regular expressions, and my favorite is this one. Some people, when confronted with a problem, think, I know, I use regular expressions. Now they have two problems. This is by Jamie Zawansky, kind of a tongue-in-cheek statement. But like many similar quotes, we may like it or hate it, but we know there is a certain amount of truth to it. And to me, the bit of truth here is that regular expressions are nice and sweet, but they can be troublesome if overused, like candy or perfume. Just to generalize a little bit, I'm a big believer of less is more. When it comes to programming, I believe less code is better than more code. There are somehow a couple of exceptions. And the very first one, you guessed it, it's crawl expressions. Have you ever had to use it? It's a pure joy to use, isn't it? Anything to do with scheduling. And it also must be amongst the most succinct syntax out there. I actually don't know anything else that comes even close to crawl expressions. Imagine your big boss asks you, Hackle, can you explain these numbers to me? And I'll have to, put a big smile on my face and say, okay, but do you have 8 hours? I'm just so grateful that nice people out there have made, great tools, such as this one. Otherwise, I would never be able to decrypt or encrypt expressions with confidence. With that said, though, I'm kind of okay with it because, well, it's first is used for one specific purpose. Secondly, it's quite well understood for those who use it. And thirdly, it's kind of well explained by tools like this. I hope you agree. It's still a bit annoying, and sometimes it makes me feel useless. Any questions? Okay, I'll move on. Our dear regular expressions can be quite a different story, couldn't it? Look at this beautiful baby. Don't you just love it? If you're not using this on production to verify email addresses, you should really be ashamed of yourself, okay? But in all seriousness, who could really understand it? I'll give you one day to decode it, and I couldn't accept the challenge. It's kind of an extreme example, to be honest. But compare regular expressions to cron expressions. So regular expressions really has no limit, at least not to its length or obscurity. There are also tools on the internet that helps us understand. They explain regexes, but often I found the explanations not much easier to understand than the regular expression themselves. Just a few fun facts about regular expressions. It's a regular language, which means it's actually a language of its own. There are also many flavors to it. There's Perl, there's PCIe, which stands for Perl Compatible Regular Expression. There's PHP, which stands for PHP. You have .NET, Java, JavaScript. The list goes on, right? As a regular language, it has its limitations, and it's not always a good idea to push its limitations. Regular expressions are wildly popular. Sometimes you can't run away from it, right? And it's occasionally vague and hard to get right. I have to define occasional, it's usual. One of the challenges with using regular expressions, or actually programming in general, is to get the right balance between readability and writability, if that's a word at all. And often when we can't get the balance, we would prefer readability because we want other people to understand our code. It's not just for ourselves, obviously. But this is not always easy with regular expressions. We usually get the opposite. It's also a regular source of disagreements if you program as a daily job between the writer of a regular expression and the reader of a regular expression. The writer, possibly after a couple of failed attempts, they would think, oh, this regular expression is glorious. And the reader on the other side would usually fail miserably a couple of times. So they would not appreciate such beauty immediately. And tell me you've never come across this. I think everybody does. And you know what? Let's be clear. I don't think it's the fault of regular expressions. Indeed, it's us software developers. I think we're notorious for, abusing things that are nice and sweet, but we keep stretching them until they break and become so likable. So what are the alternatives? Obviously, when regular expressions are getting stretched, I think parsers can be extremely handy. And this is what we're going to look at today. The agenda of this talk is very simple, hopefully. We start with the case study, which is about parsing URLs. First, we're going to use regular expressions for the job. And then we'll follow with using parsers directly without an introduction. And then, of course, we will get a proper introduction. After that, there will be more case studies with parsers. The goals, hopefully, are also clear. Well, first, we want to share the understanding where parsers can be useful. And secondly, we want to have an understanding how parsers work. We're actually going to implement a parser from scratch, okay? Exciting for you and nerve-wracking for me, a lot of live coding. And then, we'll cover the typical use cases for parsers. I hope that sounds right. Lot to cover. Personally, I value clarity and simplicity. So if you feel, during the course of this talk that something's not clear enough, you must stop me and ask, Hackle, can you explain this a bit more? Okay? Just don't be shy, just shout out. I think we'll have plenty of time, hopefully. Without further ado, we're going to jump right into a case about, parsing a REST sum URL. I don't want to call it RESTful because, people get really, excited about RESTful designs. Okay, here are the things we want to do. The task is to convert a URL to a mode object. So the mode object is the green boxes. And you can see the URLs are you can imagine they're for managing books and a library. And you would make HTTP post requests to the URLs to either create a book, edit a book, or clone an existing book, possibly to create a new one. And then based on the structure of the URL, we want to extract useful information and build the mode object. Okay, it's kind of like reverse engineering of routing. So I want us to take a few seconds to digest this because, you know, a big part of the talk kind of hinges on it. Again, if it's not clear, this is your chance to unmute and ask me any question. All good. Now I'm gonna, you know, get to the nerve-wracking part for myself. I'm gonna do a bit of live coding. If you can see Visual Studio Code here, we're gonna be using TypeScript. You think, why TypeScript? Well, I think it's possibly one of the most popular languages these days, and it's also my personal favorite. A lot of people will think, oh, it's just JavaScript plus C#, but it's so much more than that, right? You can get, you know, conditional types, type calculation, and, you know, sorts of crazy stuff, and they're officially in TypeScript. Isn't that, you know, one of the coolest things? Okay, so I'll start to walk you through the code, and then, you know, there's a part that I have to write code and you know, really have a nervous breakdown. But first of all, remember the URL schema. We're gonna produce a mode thing, you know, as a result. So a mode type, it's either a create type or an edit or clone type. And if you look at the create type, it has a mode which, you know, has to be create. For the type edit or clone, it has two modes, edit or clone, and then it also has an ID. I know some of us might ask, why don't you just do mode with create, edit, and clone with 3 modes and then ID? Well, the reason is the create type can never have an ID. Edit or clone type can never not have an ID. Okay, so this is kind of a bit of a domain modeling in the small. I hope that makes sense. Now, to be well-behaving software developers, we don't want to be cowboys, so we actually have a nice test suite and test cases for it. So this would make sense to you, but let's consolidate our understanding of the schema. You know, out of this URL, I want to get back this mode object with create. Okay, this is the edit URL, which has an ID, and that would be edit. And then there's this clone mode. Hope that makes sense. Again, questions, just shout out, I'll stop and try to explain. There are also negative test cases where none of these should work, and they should, you know, return null. And there's this nice test unit test, hopefully makes sense. But if you don't have time to read through it, you just have to take my word. And to give us all the confidence, move my windows about, so let's run the tests. That's great, demo guard is kind. So you can see the positive cases are not passing because, you know, there's a job, that's the job for me to do. And the negative cases are passing because, well, they're returning null. So the goal, of course, is to keep the negative cases passing, but we need to make the positive cases pass. Okay. Here comes, you know, the nervous part for me. We already have this parse function, which will be called here, of course. As you can see, the parse function. I'll just drill into it so that you know I'm not lying. Very simply, we have a regex expression, a pattern that we will match against the URL. If it's successful, then we will extract an ID and a clone string. If clone is there, we say, well, this is a clone mode with an ID. Otherwise, it's an edit mode with an ID. Otherwise, it's a create mode with an ID. I hope that's all very clear. Now, how do I begin? Well, I think I'll start with the most simplest one, right? Apparently create doesn't have ID, so I'll put this here, and hopefully that should work. Yes, well, who needs parsers, right? It works here. Well, can I just stop here and celebrate? But no, we need to get to edit. So how do we do edit? Well, apparently it's going to follow with another slash, right? And we want to capture the numbers. So, you know, that would be it, wouldn't it? Let me save and see it works. Well, it works for edit here, see? But it doesn't work for create. What do I do? Well, I think it's because this bit is actually optional, right? To match create. So what I'll do is to make this optional. Will this work? We're going a bit of trial and error. Oh, no, it fails edit. What did I do wrong? Well, I think it's because these pair of parentheses actually constructs a capturing group. So I'm going to say, don't capture this group. Yes. Oof, I'm on a roll. Love it. Now, how do we handle clone? I think it's more or less the same thing. So I think I'll just piggyback on edit and put another slash there. And it would follow with a clone string, wouldn't it? So will that work? See, we're doing TDD. I love that. No, it fails edit. What am I doing wrong? Well, I think it's because, well, this part would have to be optional. No. So I'm going to make this optional and put something here. Ooh, how does this look? Well, still failing. I think we have the same problem here, don't we? This should not be capturing. Success! High five, everyone. Wow. Let's take 2 seconds to celebrate. But also, let's, yeah, I'm so happy, but I think we need a sanity check. So what do I do? Let's put this beautiful baby on the screen. How do you feel? I'm full of cold sweat, but also I love it. You know, I just made this beautiful baby, and I think, you know, everybody should be able to understand. Unless if you look away for 2 seconds, like me, and then look back. Oh my God, I can't understand it anymore. What did I do? What does it mean, this thing? I can't understand it. But also, you know, I do hope that my whoever reviews my code will be in a good mood. This is so cryptic. I mean, timing is everything. I hope they review my code Friday morning. Definitely not Monday afternoon, right? They'd be in bad mood. Right, we have to move on. As I promised, we're going to be hardcore. I'm just going to go straight into parsers to get you a taste. And for this demo, I'm going to use a parsers library called Parsimmon. Why Parsimmon? Well, first of all, I persimmons, okay? My favorite fruit. It's a joy to use with TypeScript or JavaScript. And from my personal experience, it's a great library. It's very well made, well maintained. The maintainer, Brian Mork, who gave me their blessing for this talk, is an extremely helpful person. So I would highly recommend that you try this out. They also have a sister library called Bread and Butter. Now, the naming is just incredible. You should totally check that out if you're interested. With that said, there are excellent parsers libraries out there for any mainstream languages. So you will have no problem finding your favorite, okay? So this, it's just for good demo today. Without further ado, again, we're going to jump right in. We're going to go to this, you know, this parsers file. Before we do that, though, of course, we're going to reuse the same test suite, okay? So I'm going to import the same function from the parser file. And just to show you that I'm not lying, that all the tests are, you know, failing again. And then this parser function, well, we have this URL parser that's not quite defined, and currently it's returning a empty mode object. So you should be failing all the test cases, positive test cases, excuse me. And if you look at, just the first impression, how parsers work, you run the parser against the URL here. If it's successful, we return the value from the result. Otherwise, we return null. Okay, hopefully that's a very simple thing to understand. Okay, again, the nerve wrecking part. I'm going to create a URL parser. Live coding. Oh my God, what did I get myself into? I'm gonna be very declarative because I like declarative programming. What do? I will start from top and go to the bottom. Just get a load of the syntax. Okay, I think the URL parser in our schema, there are three alternatives. There is clone. I'll start with the most specific one. Clone with an ID and a clone string. Okay. And there's edit and there's create. How does that sound? I hope that's that makes sense. So we now need to create the three parsers. Okay, so clone, edit, create. They're actually parsers within parsers. Okay, so easily I'm going to create a create parser. Well, if I remember well. The create parser is simply this. Okay, it's just this string with /book. Okay. Well, it's not going to make the test run, but I'm going to go on to create the edit parser, which will be, if I can type, well, I think it would be create actually, followed by a slash. So I'm going to say it's followed by a slash in this way, and then followed by a book ID. And again, I'm going to be declarative. I'll just create one called book ID. And now, of course, mind you, I have to create a book ID parser. See, they're all parsers. So we're getting a load of parsers. What is a book ID? I think is a digit. Now, the syntax might be a bit foreign, but hopefully, if you calm down, you can understand it. It's at least one digit, right? We don't want to get an empty string. And then I am going to join all the digits together because all the digits will come in as an array. So a bit of JavaScript. We join the array of digits into one book ID. Hopefully that makes sense. And we have one last thing to define, of course. The clone parser will be the edit parser followed by /clone, right? So I'm going to use another thing called skip, followed by string of clone. Does that compile? It doesn't, of course, because TypeScript is going to tell us the types don't match. So I like the parsers created, but I do have to do a mapping. Just so that I know that clone and edit parsers will give me the ID. We'll figure that out later if you think this is a bit confusing. But if I take the ID, I can create an object with the ID and the mode. And the mode would be clone here. And the same happens to edit, just so that I know that ID will be the result of the edit parser, and the mode here would be edit. Gotta love the auto-completion. And the create thing, it's most simplest. I don't really care about, what's the result of the parser because, we don't need an ID. So I am just easily going to give it a mode, create. Yes, it all works. Told you I was on a roll. Now let's take just a few seconds to look at this. I hope this declarative way of making a parser make sense to you. We're simply saying the URL schema is either create, edit, or clone. And how are they created? They're actually created iteratively in terms of each other. Okay, any questions at this moment? Okay, comfortable silence, I'm okay with that. That is just to get us a taste of Parsimmon and parsers in general, okay? So I'm quite sure you have questions if this is new to you, but we'll get to it later. So far for our example, it would seem that parsers do about the same thing as Regex. And given the context we have, I think it's a fair thing to say because they're solving the same task at this moment. But even without going further, we can see there are a few differences. Well, first of all, quite obviously, parsers are more explicit. We're writing more code, but hopefully they're less cryptic. Secondly, this is less obvious, but using parsers kind of require a different flow. Now, what do I mean by that? With regular expressions, usually 3 steps. So we match a regex pattern against a string. If it's successful, we extract the capturing groups out of the match. And then we build the mode out of the captures. Of course, sometimes you just need to match, right? Sometimes you don't really want to build something out of it. But this would be a pretty general summary of the workflow. With parsers, it's slightly different. As you can see, we select or skip data conditionally. So the terms that I use, the functions that I use, the then function and skip function, they conditionally ignore or capture something. And then we build the mode object, the result, on the fly, but piece by piece. See, we have IDs and then we ignore some data, eventually build the mode object. And also, kind of strange, parsers, they're just functions. So we must apply the parser in the end to get the result. Of course, parsers are so much more than what we just seen. But before we go any further, let's make a brief but more proper introduction. So what are parsers exactly? Well, it's a good source of truth. Wikipedia is where I usually go to my first attempt. But like many technical terms, pages, this is quite dense, and I try really hard, but I think I can pick out a few keywords here. For example, parsing, it's kind of equivalent to syntactic analysis. It's used for natural languages, programming languages, or data structures. It's also an essential part of making compilers for programming languages. I must admit that was a bit overwhelming, the Wikipedia page. Luckily, there were great people out there who didn't mind, dumbing it down for the likes of me. They even made a rhyme for it, although I never found the tune, so I guess we'll have to improvise. It can be jingle bell, right? Like a parser for things is a function from strings. Yeah, I mean, I practiced for weeks. That's the highlight of NDC Sydney, right? No doubt. Does anybody want to try a rap version? Any challenges? No? Your loss. My version is still the best. But feel free to post your video in the Slack channel if you do want to try. If I'm allowed to oversimplify, grossly so, oversimplify it even further, a parser is just a function that turns a string into a thing. Remember the rhyme? A parser of things. I'll keep saying this until you get so bored. So it just turns a string into a thing, and it's a function. Okay? But how is it done? Well, parsers are kind of like cute crocodiles. Look at it. This cute crocodile would eat the string part by part. If it likes the part, then it spits out a small thing. If not, it would stop the whole job. And then it keeps eating, and it keeps spitting out more and more small things on the fly. And then the final big thing is built by putting all these small things together. If the crocodile, gets to the end. So why crocodile? People say. Well, it's because I've seen the video of two Aussie mates bossing a crocodile about. Have you seen that video? You're a nuisance. Stay put. I never like crocodile cartoons. I never thought they were cute. I mean, they can kill you, right? Until I saw this video, and then I was like, whoa, okay, now I got it. They're cute to the Aussies. Okay, enough theory on crocodiles. Let's look at some solid example. See, we have the string that apparently is an addition, right? It adds two numbers together, and we want to parse it, evaluate it, and get the result of the addition. Now, how is it done with parsers? Well, actually, we're not quite done with cute crocodiles. Yeah, it's gonna be a good meal. Digitalicious. That's the word. You can see the crocodile takes 4 steps to get to the end. Well, first of all, it eats 2 digits and spit out 12. And then it keeps eating. It eats the plus sign. And it's going to spit out a addition function, called it an operation. And thirdly, is going to keep eating and eat the last 2 digits and spit out another number. And eventually, it's going to apply the addition operation to the 2 numbers that we get from the result. That's the result. Righto, more live coding. I hope you're ready for that. Well, actually, more like copy pasting, because I don't think we have enough time for me to do that. As a slow typist I am. We're going to create, this is where we create a naive parser from scratch, okay? If you're ready, I hope you remember, 12 plus 34. We want to solve that with a naive parser that we're going to build, right? A daunting task, right? We're going to build something magical from scratch. Well, first of all, we're quite type-driven, actually. So we're going to start with declaring a couple of types. The result for the parser, which has a value, and the rest of the string, remember? It eats it part by part, so there would be the rest. And then we have a parser, which is a function, remember? It's a parser of things is a function from a string to result, okay? And then we have the symbols. That we have a notation, which is a simple function that, either adds or, or multiply 2 numbers together. Hope that makes sense. We're going to list out all the possible digits. Very explicit. All the symbol characters. Also create a simple helper function here that converts a symbol to a function that either adds, or subtracts, or multiplies the number. Hope that makes sense. Okay, it comes to the exciting part. This is how a parser is really built. This is the most basic parser. Remember, the crocodile is going to eat a string part by part, but really it does that 1 character at a time. The parser is just a function, remember, it's the rhyme. And if you look at the implementation of this, this char parser, it's very simple, right? It says if the raw string it's empty or null, well, fail immediately, otherwise we want to take the first character and return, and keep the rest. Does that make sense? questions, feel free to ask. We're going to slowly move on to this strange parser. This is also a parser called satisfies. And it takes two parameters, okay? One is a parser itself, we call it parser one. There's also a predicate. All it does is to intercept the result of parser one and only return the result if it satisfies the predicate. As you can see, the implementation does exactly that. But there's this recursive pattern, you know, if the result is already null, don't do anything, just return null. I hope that makes sense. You have to get used to functions within functions, but that's, you know, that's what the rhyme tells us. Okay, there is this mini parser. This takes one parser and keeps applying this parser one until it fails and puts all the good results before it fails into an array. You can see there's a bit of recursion here. You know, it keeps going to next. So you can see the pattern here. Results null, then return immediately. Okay, it keeps adding to the array. Many. And then we have a map function. Hopefully we're very familiar with the concept at least. What it does is to take the result of parser one and convert it from type T to type U. So it's just like map for an array or a list. As you can see, the implementation does exactly that. Okay, these are actually the fundamental bits, or at least just the bits that we need. Now comes the real exciting part. We're going to compose these building blocks. There are only about 4 or 5 of them, aren't they? We'll say digit as a parser, it's just a char parser that satisfies this condition. That its result, it's in these characters, you see? Makes sense? Slowly, we're going to move on to the plural form of digit. It still satisfies, but this it's saying digits is many digit with at least one digit in it. Okay? So this would be an array of string. What's a number parser? I hope you're slowly getting bored with this repetition, but that's good because you're getting the idea. So the number parser, it's the digits parser mapped to a number. Remember, digits parser, it's parser that returns a string array, okay? What's the symbol parser? It's just a character that satisfies this condition. I hope you do feel the boredom. We're getting very repetitive, which is great. The operation parser, it's just a symbol parser that's getting converted into a operation function. Easy as. And we get to the evaluate function. There's a lot of code, I regret, but the idea is very straightforward, hopefully. It tries to match, it tries to eat a number, right? And then it tries to eat an operation. Then it tries to get another number. If all successful, easy, we're going to apply the result of operation parser, which would be a function, and apply that to 2 numbers. Now, would this work? Well, as well-behaving software developers, we have another test suite and plenty of test cases. Now, if my arithmetics still works, I hope the results are correct. Otherwise, we have a big problem. But let's run this test suite. And right out, they do work. So, you believe it, we take about 5-10 minutes and we created a parser from scratch. How do you feel? Okay. It's the time to ask questions, okay? But hopefully everybody's getting the idea, if not verbatim. Well, we implemented a parser. Is there a question?
Yeah, just a question. In terms of performance, how are parser performing compared to Regex?
That is a great question. I will get to it later if you don't mind.
Sure, not a problem.
I promise. Thank you. Good question. I love it. Well, we just created a parser from scratch, right? Which is great. But of course, in real life, you possibly don't have to write your own parsers. Unless you're really obsessed, which I know some of us must be. It's so easy, right? You just got to do it. Developers. But sometimes we just use a library. They're quite well-made, well-maintained, proven. When we do use a library like Parsimmon, there are terms that we use regularly to get most jobs done. So you can see there is sec for sequencing a few parsers. There is alt for choosing from alternatives. There is map, seeing. There is many and at least to handle repetitions. There is off and succeed. They just succeed without consuming any characters. There is also parser.regex. I told you I was kidding. We still need regex. But not all parsers use regex, you've seen that. But they're not mutually exclusive. And there is also skip, and then they just conditionally capture or ignore things. They're like special maps. Hope that all makes sense. Again, if you use another parser library, there are so many good ones out there. The terms would be slightly different, but the hopefully would be quite similar. Okay, well, we've actually done the live coding, but there's something else I want to do. If we're going to go back to the URL examples, say one day, we decided that integers are not really good. They're not really the best option for book IDs. Have you come across this? We want to switch to GUID. But before I show you any code, I want you to take a few seconds to think about how you would use regex to match this, this GUID string. It's on the slide. Now, also remember, anything will be more code than regex, because regex just so dense. But arguably, many other options are more clearer. And the key point of this is that I want to show you that parsers are very easy to compose. Okay? So the solution, hopefully, you'll see, it's quite simple, in my opinion. We're going to reuse the same URL parser, but here we're going to use, instead of book ID with digits, we are going to change it. We're going to use something called GUID. Okay, so GUID is actually a parser, which I've defined here. I'll drill into it for your benefit, but also I am going to run well-behaving software developers. We need some test cases. So I'm going to run that. Of course, all parsers, if you look at them, what is the magic? I hope this is straightforward to you. I like this GUID parser. It just reads out perfectly, doesn't it? A parser for a GUID dictates that the structure of GUID, it's 8 hex characters followed by dash, then 4, followed by dash, then 4, 4, then 12. Eventually, we join them together. Does this make sense? Now, just a quick comparison. This is what we will get with a regular expression. Notably, it's not the regular expression, but personally, I think I like this a bit better. Of course, I would have to show you that hex is a helper function that takes a length and it's the hex character parser, which is defined here so many times, and join the result together as a string. But you can see we're being very explicit here. If you're using Parsimmon, a good parser library, because there are more succinct ways to do that. But here I'd like to be more explicit. Let's take another look at this beauty. Don't you just love it? What I forgot to show you actually is that I was going to implement the calculator in with Parsimmon as well. Let's quickly go over that, if you excuse me. As you can see, the types are quite similar. We also have the same converter function that converts symbols to small functions. Hopefully that's quite straightforward. What about number? Well, it's many digits. Remember, at least one digit. And then we join them together. What about operation? Well, it's one of these symbols, and then we map it to a function. I'm going to go a bit slower. What about arithmetic? Well, it's just a sequence of number, then operation, then a number, and then take two numbers with a symbol, with the operation function in between. I apply this operation function. And how do we calculate it? Hopefully you've seen this a lot of times. We use the arithmetic parser to parse the raw string. If it's successful, we return it. Otherwise, we'll return null. So a bit of back and forth. Sorry about that. But hopefully this makes sense to you. This is the GUID that we just covered. Now, I know some of us will think, oh, well, that's nice, but I can also do that with Regex if I stretched it just a little. What's the big fuss with parsers, right? Well, there is much more to parsers. Remember, it's used to make programming languages, so it can get quite complex. But without getting to very advanced case studies, here's an example that you will very possibly run into if you're lucky or unlucky, depending on your perspective, of course. This is some sort of, oh, somebody should have told me, sorry, my fault. This is the recursive syntax that I personally ran into in real life. It's possibly kind of like JSON, but not quite, you see. It's from a time when there's no standardization and people just had a blast inventing their own things. And, then a couple of weeks later, other developers had to suffer from their genius. Yeah, perfect example of that. So it's also saved in the database as a text field. So I had to parse it and get information out of it. How's that? Now, this is something that would be impossible, if not very difficult, for expressions, because it's a regular language. Although I'm aware there are very powerful regular expression engines out there, so I would rather not say never. But for my experience, this would be quite difficult. And this is where I would really need a parser. And on that note, let's bring in this baby. Okay, first of all, we call this data structure, we call it angle, okay, because of the angle brackets. Now this is a valid angle object. 21 is also a valid one, just one single value, and a string is also a valid angle, okay? Now we define the types here, and I want you to mind the recursion, okay, with TypeScript. Don't you love it? So an angle data structure is either a number or a string or an array of entries but the array of entries, or each entry, it's a key value pair, but the value itself can be an angle. See, there's a bit of recursion, okay? We also have a helper function that converts a angle object to a JavaScript object recursively, okay? So this can be a bit dense, but it just goes through the whole array and builds things. And here you can see it's calling itself. Okay, so how do we get this, how do we parse this nasty angle string? Well, first we bring on an old friend, the number. I hope you are very familiar with this now. See, there are patterns that you would come across very quickly when you start using parsers. There is this quote thing. See, I'm being very explicit. I just define a small parser for everything. I'm having a blast. And there is a quoted string, which has this parser that keeps eating characters until another quote is met. So a disclaimer: this is a very simple implementation. We're not considering escaped quotes or nasty things like that. And that string will be wrapped in 2 quotes. Okay. I hope the syntax, the fluent syntax, it's self-explanatory. So we have quoted strings. Remember, quoted strings can be a value or the field name, okay? We have a key value pair parser, which takes a child parser and builds a key value string here, you see? We have a quoted string as the field name. We have a dot in between, then we put the child in there. And then with this map thing, we ignore the dot in between. You see, we just leave it out because we just need the key and the value. But note, the child itself can be a angle parser, you see? So there's a bit of recursion there. Now we define the parser for an object. Again, we use the same pattern. There's a child. We build a key value pair, but then we say we want to repeat it, and there should be at least 1 pair. So we get many key value pairs, which, the value of the child could itself be a parser. So mind the recursion. And then we wrap them in a pair of curly brackets. Not curly, sorry, angle brackets. And then we map it using the helper function we had defined above, map it to a JavaScript object. I hope that makes sense. And we're going to bring it all together. What is an angle parser? Angle parser, it's a lazy parser. Okay, so lazy is what makes recursion possible. And angle, as you can see, can have 3 alternatives. Remember the types, it can be either a number or a string that's quoted, but also it can be recursive. So angle is defined in terms of itself. See, that's also something that's only possible with this lazy function. Okay, how do we use it? Well, we've seen that so many times. I hope, again, you're getting so bored with this. Well, we use the parser to parse it. If it's successful, we return the value, otherwise we return. And does this work? Again, I don't want you to just take my word for it. Oh, it does work, doesn't it? So all the positive cases, negative cases, they just work as expected. I'm aware this could be a bit overwhelming if you just new to parsers, but I hope you get the idea that it's composable, and you just make small parsers and add them together. You have a pretty big one, like this one here. In the end, they just bring things together. Okay, just be conscious of time. If I have to make a recommendation, when to use regular expressions? Well, For dynamic string search, accepting user input, for example, you want users to give you a regex, and then you can search in your database, with a regex match. But if you do that, do watch out for regular expression denial of service. There is a OWASP page that you can read up on. Well, secondly, if you want to achieve readability, you possibly want to prioritize using regex because, well, if it's simple, why bother with a new library, right? So go for it if you can achieve readability. Now, to answer the question that was previously asked, sorry about the delay, maybe for performance. Well, why? Because some of the regex engines out there, they're really well made and they're proven. They're battle tested, they're really performant. So if performance is a big problem for you, then maybe you want to consider regular expressions first. However, with that said, remember, there are well-made parsers out there as well with great performance. However, you might want to assess yourself if it's really business critical for you to have it run fast. Well, eventually, when you don't have a choice, we don't have a choice. For example, some configuration files would require you to use regex, then you don't have, you can't write code for it. You don't have a choice, really. Well, when would I recommend for us to use parsers? Well, obviously, when something's not simply solvable with string comparison or regular expressions, or typically when readability is hurt, which is, why we have this talk really. Or if you want to take things to the next level for the full power of parsers, if you want to deal with custom syntax, clever schema that were invented by, clever developers before you, which is unfortunately my case in real life. Well, that was fun, as it turned out. Or if you want to go crazy and create your own language from, a mini language to a fully fledged language, actually. If you look at Parsimmon, they actually have a thing that facilitates creating a language for you. Think about that. Or simply for fun. Parsers are amazing and they're just a joy to work with. So yeah, try it out. Well, I hope you didn't fall asleep during this long talk. I'm just conscious of time. If you did fall asleep, I hope you slept really well. The code examples will be on my GitHub account. So just search, Hackle W, I guess. And also, please reach out anytime if you have any questions. I'll hang around the conference. But other than that, thank you very much, everyone.